Section 5.3 moves away from direct variation and gets into what we call slope-intercept form. There's actually several forms of equations that we're going to learn about. The first one, probably the easiest one to learn about, that's why it's first, is slope-intercept form. There's a pattern to graphing linear equations that we're going to discover. Actually, we discovered it when we went to the computer lab. But officially, we're going to discover that pattern today. We're going to graph some equations using a table. That's just good practice. Lots of times you got to graph equations using tables, and we're going to do that here. And then we're going to see if we can discover the pattern, just in case what we did in the computer lab yesterday didn't make any sense to you. So we have 4 equations that we're going to graph using a table. When I graph using a table, I set up my x and my y, and in the middle column I'm putting my function, 3x minus 4. I should pick some easy numbers. So let's go with, since we're not looking at any fractions here, let's go with -2, -1, 0, 1, and 2. Slope-intercept form removes the need for us to do this. So it is really nice when you figure out that pattern and you can use that pattern to graph every time. You don't have to use the table anymore. So try to learn this pattern. Okay, I plugged the -2 in, so I'm showing my work in this middle column. 3 times -2 minus 4. Well, 3 times -2 is -6. -6 minus 4 is -10. Then I have -1. Substitute in my -1. So 3 times -1 minus 4 gives me -7. 3 times 0 minus 4 gives me -4. 3 times 1 minus 4 gives me -1. And 3 times 2 minus 4 gives me 6 minus 4, which is +2. Now that we have those ordered pairs, we can graph them. So I have -2, -10. Well, that's way off my grid, so I can't graph that one. -1, -7, that is on my grid. It's right there. Then 0, -4 is right there. And then 1, -1. Here's 1, and then -1 is right there. And finally 2, 2 is right there. Seems like all of these dots are kind of making a line, and they are making a line. So I'm going to go ahead and put my ruler on here and draw in that line. Line up your ruler really well. Get that line on there drawn very accurately. All the way through the grid, arrows at both ends. For the second one, I'm going to do the same thing. Set up a table, x and y. Put my function in the middle, 3x plus 1. I don't have any fractions to worry about, so I'm going to go with -2, -1, 0, 1, and 2. And we'll see where that leads me. I plug in my numbers. 3 times -2 plus 1. Well, that's -6 plus 1, which is -5. 3 times -1 plus 1. That's -3 plus 1, which is -2. 3 times 0 plus 1 gives me just 1. 3 times 1 plus 1 gives me 3 plus 1, which is 4. And then 3 times 2 plus 1 would be 6 plus 1, which is 7. Plot those points. We have -2, -5, so that's down here. We have 1, -2, so that's right there. We have 0, 1, so that's right there. We have 1, 4, so that's right there. And then we have 2, 7, that's right there. Again, it looks like a line. So I'm going to draw in my line very carefully, very accurately. There you go. All the way through the grid and arrows. So for this one, same thing. Set up a table, x and y. Function goes in the middle, -1/2 x plus 3. I want to choose some easy numbers here. What easy number should I choose? -3, -1, 0, 1, 2, 3. Those are my usual easy numbers, but let's think about those numbers for a second. 2, 4, 6, negative 2, negative 4, negative 6. Going to be a little bit better. Why? Yeah, because of this 1/2 right here. I don't like working with fractions any more than you guys do. If I can avoid it, I will. So if I think about this, I'm going to multiply my numbers by 1/2. That's going to be easy to do if I'm working with even numbers. So instead of negative 3, negative 2, negative 1, 0, 1, 2, 3, I'm going to pick negative 6, negative 4, negative 2, 0, 2, 4, 6. Maybe I don't need to pick that many numbers. Maybe I could leave that negative 6 and the positive 6 off. I don't know. But for purposes of this example, we'll go ahead and go with that negative 6. So now I write negative 1/2 times negative 6 plus 3. Well, negative 1/2 times negative 6 is going to be positive what? 3. And then 3 plus 3 is 6. And then negative 1/2 times negative 4 plus 3. Negative 1/2 times negative 4 is positive 2, and then 2 plus 3 is 5. That was correct. Same thing, negative 1/2 times negative 2 plus 3. Negative 1/2 times negative 2 is positive 1, plus 3 is 4. Negative 1/2 times 0 plus 3. That one's easy. What do we get? 3. Negative 1/2 times 2 plus 3. Now it's negative 1/2 times positive 2, which winds up being negative 1 plus 3 is 2. Then we have negative 1/2 times 4 plus 3. What do we get? 1 is correct. And then we have negative 1/2 times 6 plus 3, which is 0. So you might notice a pattern that showed up on that right-hand side. 6, 5, 4, 3, 2, 1. If I were to keep going, I would start to see that pattern continue. Negative 1, negative 2, negative 3, and so on. Okay? So there are patterns. There's always patterns in math. And in algebra, you really want to notice those patterns because it helps you with that math as you go on. So we want to plot these points here. We have negative 6, positive 6. We have negative 4, which is there. Positive 5, which is there. We have negative 2, positive 4. We have 0, 3. We have positive 2, positive 2. And then we have positive 4, positive 1, and then finally we have 6, 0. So, looks like a line, draw it in there. If it feels like this is taking forever, hold on to that feeling. It'll make you appreciate the pattern that we're going to talk about here, slope-intercept form, all the much more. All right, go ahead and do that last one because it's good practice. I chose even numbers because I have that 1/2 times x. If I had 1/3 times x, then I would probably choose numbers that are multiples of 3. If I had like 1/5, I'd choose multiples of 5, and so on. Okay? So you're always trying to find multiples of the denominator so that you're not working with fractions. It makes life a lot easier. I chose negative 4, negative 2, 0, 2, 4, and now I just need to fill in my numbers. What do I get for negative 4? Positive 2 minus 2 is 0. What do I get for negative 2? Negative 1. What do I get for 0? Negative 2. What do I get for 2? Positive 3. Negative 3. Okay. And what do I get for 4? Negative 4. Okay, so I graph that. Negative 4, 0 is there. negative 2, negative 1 is there. 0, negative 2 is there. 2, negative 3 is there. And then 4, negative 4 is there. Seems to have made a line, so I'll graph that. One more very careful line drawn through all of my dots with arrows at both ends. Before we move on, I want to take a look at these graphs and see if we can find some patterns here. First of all, without looking at the graphs, without looking at the tables, what do you notice about these equations? There's actually a pattern going on in the equations themselves. Look at the top two equations. What do you notice? So in the equations only, we have y equals 3x minus 4. And then the other one we had y equals, the 3x is still there, but now it's plus 1. Okay? So now look at the graph. We have y equals 3x minus 4, y equals 3x plus 1. What do you see in the graphs? This number right here is the y-intercept, where the graph crosses the y-axis on that one. This number right here, same idea. It's where the graph crosses the y-axis. Okay? The shape of the line is the same. It's just that the line is going through a different spot, because all we changed here was that number, that last number, that constant number. Same thing is true on this one. We have y equals negative 1/2 x plus 3. We have y equals negative 1/2 x minus 2. If you look at the plus 3 here, and then you look at where the line crosses the y-axis, it's going through 3 on the y-axis. If you look at the negative 2 right there, and you look at the y-axis, that line is going through negative 2 on the y-axis. Okay? So the result is, like, what can we say? What's the conclusion from what we see here and this number? It's the y-intercept. Okay? So the number that you see at the end that doesn't have the x on it is the y-intercept. What if you didn't see a number at all? Then it would be direct variation, and direct variation graphs go through the origin. So actually, what is the y-coordinate at the origin? 0. So if you didn't have a number here, it would be kind of like saying plus 0. So really, actually, that number is there. It's just a 0, which tells you to go through the origin. Okay? So this number right here is always the y-intercept. There is one more pattern to talk about in these graphs. Notice that I said the shape of this graph stayed the same. The shape of this graph stayed the same. The shape of this graph from here to here also stayed the same. The only thing that changed was the y-intercept. So in the graphs, what stayed the same? The slope stayed the same. What is the slope of this graph? 3, up 3 over 1, up 3 over 1, up 3 over 1. In my equation, do I have 3 over 1 somewhere? Yes, I have a 3 over 1 sitting right there. What's the slope of this one? It's also 3. From here I go up 3, right 1, up 3, right 1, up 3, right 1. The slope of this one is also 3. That 3 on the x stayed there. Okay? On this one, what is my slope? 1/2. Is it 1/2? It's negative. This line goes down from left to right, so the slope must be negative. From here I go down 1, that's where my negative comes in, and then I go right 2. Down 1, right 2, down 1, right 2. This slope is negative 1/2. On this equation, do I see a negative 1/2 somewhere? Sitting right there, attached to the x, just like the 3 was attached to the x here. What's the slope of this line? Negative 1/2. Down 1, right 2, down 1, right 2. And again, that negative 1/2 is sitting there attached to the x. So, what conclusion can we say about slope and my equation? Slope is attached to the x. The y-intercept is not. But both are sitting there as long as I have y equals. Okay? And that is slope-intercept form. Slope-intercept form says y equals, what letter do we use for slope? mx plus b, and b is the y-intercept. So, just from those four graphs, we now know what slope-intercept form is. Y equals mx plus b. This is an equation that you have to have memorized. That's like our second one from this chapter. There's going to be a bunch. So, what is m? Slope. It's not mx, it's just the number m. Okay, so if I ask you what the slope is, don't say like 2x. It would just be 2, just the number. And what's b? The y-intercept. What is the y-intercept in words? Where, good, the graph crosses the y-axis. That number right there tells you where the graph crosses the y-axis. From there, you put that dot down. From there, you use the slope, and from that, you can graph the line very easily. You can get away from using tables, which is a very nice thing. Those 4 problems that took us 10 minutes to do using tables, we could do now, with practice probably, but we could do probably in about 30 seconds. So it's a huge time saver. So now we're going to get into a bunch of different types of problems that I can ask you based on slope-intercept form. So for example, what is the equation of the line shown in the graph? Well, to do that, because it's a line, I'm going to try to write this in slope-intercept form. So y equals mx plus b. Which means all I got to do is figure out m and b. Once I do that, I have the equation. So I'm going to rewrite this. Y equals, the easiest thing to figure out is the y-intercept. What is the y-intercept on this graph? Right here, 2. So I'm going to put plus 2. What if it was negative 3? What would I write? Minus 3. Okay? Now there's going to be an x here, and then I got to figure out what the slope is. Got to figure out that number. So all I got to do is find another easy point. I already have the y-intercept right here of 2. Look around and find another spot where the graph crosses the grid. Not here, not here, not really there. If this line extended out a little bit farther, that would be my other dot right there. Now do rise over run. Down 3, right 4. Down 3 means negative 3 over 4. So there's my slope, and there's my equation. Should the slope be negative? Yeah, because that graph goes down from left to right, okay, on this particular graph. So how long does it take to check to make sure you got the right sign on your slope? Like 0.3 of a second. So just double check. Negative should be going down from left to right. Got it. Now it's just a question of if you got the numbers right or not. Another way that I can ask you questions involving slope-intercept form is just to have you identify what the slope and y-intercept are for each equation. So all you got to do is know that y equals mx plus b means that m is the slope, it's the number that's attached to the x, and b is the y-intercept, it's the number that is just by itself. Okay? So in this equation, y equals negative 2x plus 6, what is the slope? Negative 2. So I'm going to write m equals negative 2, because m means slope, and we're in algebra, so we all know that. So we can write m equals negative 2. And the y-intercept, we have this 6 sitting right here. Technically, 6 isn't a good enough answer. We're going to write y-intercept, int, is good enough. And I'm going to put a colon there. And then I'm going to write that one as an ordered pair. The ordered pair for the y-intercept is 0, 6. So there's my answer. Or there are my answers, I should say. So let's talk about the slope and y-intercept for the second one now. What am I going to write? M equals 3. And needs to be an ordered pair, and it's always going to be 0, and then this number, negative 5. It's an ordered pair, so we have to write it like an ordered pair. Okay, go ahead and do the last one. All right, what do we got? M equals 5 is 0, comma 0. Good. It's 0, 0 because I don't see a number here. This is actually direct variation right here. This would actually, if I wanted to write a number there, I'd have to write plus 0. And that then becomes the y-intercept, 0, 0. Okay, good. The slope here is 5. The slope is always attached to the x. If I don't see an x in an equation, then the slope is 0. We'll talk about that a little bit later. What we're going to do next is where slope-intercept really shines. If I give you a slope and I give you a y-intercept, you have all the information you need to not only write the equation, but also graph the line. There's no need anymore to write a table down. So if I give you a problem like this, write an equation in slope-intercept form for a line with a slope of 3/2 and a y-intercept of negative 3. We can do that immediately because all we need to write an equation is the slope and the y-intercept. I can write y equals 3/2 because that's my slope, x because the slope is attached to the variable x, and then minus 3 because we have y equals mx plus b, and my b in this case is negative 3, so I write minus 3. That's my equation. Okay? Very little work to do. You just got to recognize how to put things in slope-intercept form. Now it says graph the equation. Previously, we would have to draw a table like we did in the beginning of this class today, but now we don't have to. Start at the y-intercept, which is negative 3. So I go to my y-axis, and I go to negative 3, which is right there. I'm going to put a dot. Then from the y-intercept, use the slope. The slope is a rise of 3, a run of 2, 3/2. So from here, I'm going to go up 3, 1, 2, 3, and over 2 to the right, 1, 2, and put a dot. And I'm just going to repeat that and get as many dots on here as I can. Up 3, 1, 2, 3, over 2 to the right. Up 1, 2, 3, over 2 to the right. I'm out of room, reverse it, go back to the beginning, the y-intercept, and go the other way. Instead of up 3, down 3, instead of right 2, left 2, and I can get one more dot on there. Now I have all the dots I can put on there, so I can bring my ruler up and very carefully and accurately draw in my line. And I'm done. With practice, doing a problem like this will start to take less and less time, to the point where you could probably do a problem like this in maybe 10 seconds. I don't want you to try to take 10 seconds now. I want you to be good at it. But once you get good at it, you'll see how much faster you can go. We have 2 more problems to try, exactly the same way. First, write the equation, then graph the line. Go ahead. So let's first write the equation here. I'm given everything I need. I'm going to write what? Y equals negative 1/2 x plus 3. That's the equation. How do I graph it? I start at 3 on the y-axis, which is right there, and then I go from there. Get in a habit, all right? Always either do rise first, up or down, and then go right, or do rise up first and then decide whether you got to go left or right. For me, I like to take care of the negative sign immediately and either go up or down. And that way, I always go to the right when I do my run, okay? That's the habit that I'm in. Whatever habit you want to form, that's fine, okay? But stick with it and that will prevent mistakes. So for me, I see that negative 1/2, I'm going to go from my 3 down first. Down 1 and then right 2. And then I just do it over and over. Down 1, right 2, down 1, right 2. Then I reverse it. Up 1, left 2, up 1, left 2, up 1, left 2. And I'm out of space. That gives me a negative slope for my line, and I can go ahead and draw that one in. I really, really recommend picking something to do first always. and then sticking with it. For me, I'm going to go up or down first, and then I'm going to go to the right every time. My second one, I need to write my equation. What will I write? -1. Good. Okay, how do I graph that? Start at -1 on the y-axis, so I go to here. Now what do? I rise 3, run 1. Okay, this is one of the trickier things that Algebra 1 students will forget about. This is actually 3 over 1. Okay, there's always a run. So if you just see a number here, put it over 1 for now, and that will help you remember that you still need to run. Because if you forget to run, you're just going to go up 3 and put a dot here. And then you'll have a vertical line, and that's not what this is. Okay? So we need to rise 3, 1, 2, 3, and then run 1, and then over and over. Up 3, over 1, I'm out of room, reverse it. Down 3, left 1, down 3, left 1, I'm out of room. That's all the dots I can put on there. Draw on the line very carefully. Probably use pencil, it's a good idea. And there we go. So lots of different ways I can ask you questions about slope-intercept form, and those ways are checked on 7 through 27. So that's like 21 problems right off the bat. Some of them will take a little bit longer than others, but you're capable of doing all of them, and I'm going to give you some time. Go ahead. Are these equations in slope-intercept form? Is this one here in slope-intercept form? Actually, it is. It's in slope-intercept form because it's y equals, okay? Slope-intercept form looks like y equals some stuff. If you have y equals some stuff, then it is in slope-intercept form. Is this one in slope-intercept form? No, it's not. To get this one in slope-intercept form, what do we need to do? Divide both sides by 2. So now I have y equals 1/2. So I'm saying it's in slope-intercept form. We know that slope-intercept form is y equals mx plus b. And we know that the b is the number that's by itself, and we know that the m is the number that's attached to x. In this problem, is there an x? No, there's not an x. In order for there to be not an x, I could think of this equation as like something x minus 3, but what must that number right there be? 0. If I have 0 times something, then that turns into just 0. It disappears. Then I'd have 0 minus 3, which is -3. Okay? So on a problem like this, if you don't see x, then the slope is what? 0. And what you're looking at right here is only the y-intercept. So the y-intercept on this graph is -3, which is right here. And the slope is 0, which means that this line is what? Horizontal. That's right. So we're going to draw in a horizontal line here that goes through -3. That's supposed to be horizontal. How about that second one? Have a seat. Is this slope 1/2? Do you see the x attached to the 1/2? No. So this is not the slope. This is the y-intercept again. I could rewrite this equation as y equals 0x plus 1/2. The slope on this one again is 0. The x isn't there. Just like if you don't see the number, then the y-intercept is 0. Okay? We have the number, we don't have the x. So we go to 1/2 on our y-axis, which is right there. And what kind of line will we draw? Another horizontal line. So make sure you're careful. If you don't see the x, then what you have is a horizontal line that goes through that number that you're seeing. In this case, 1/2. In the first case, -3.